Hello everyone and welcome back to the channel. In today's video we are diving into Constexpr, a powerful feature in modern C++. It allows you to write faster and more efficient programs by evaluating code at compile time. Now, if you've ever wondered what Constexpr means, when to use it and how it can make your code better, stick around because we are going to break it all down step by step. So what is Constexpr? Let's start with the basics. The keyword Constexpr stands for constant expression. When you mark a variable, function, or even constructor as Constexpr, you are telling the compiler, hey, this should be evaluated at compile time, if possible, especially in scenarios where you are doing a lot of repeated calculations or need values that will never change at runtime. Here is a very simple example. In this case, the function square is marked as Constexpr, and since we are passing in a constant value of 5, the compiler computes the result during compilation. That means no actual calculation happens at runtime. It's as if you wrote the result's value directly. But why should you care? When code is evaluated at compile time, it reduces runtime overhead, it can make embedded and performance-critical systems much faster, and it can enable better optimizations by the compiler. Imagine you are programming for a microcontroller with limited CPU cycles. Every computation saved during runtime counts. Or maybe you are writing template-heavy C++ code where compile time values control how types or functions are generated. There is a common confusion between const and Constexpr, so let's clear that up. Const means the value cannot change, but it might be determined at runtime. Constexpr means the value must be known at compile time. Here is an example. You can think of Constexpr as a stricter and more powerful version of Const. Starting from C++11, we could write Constexpr functions, but they had to follow very strict rules. They had to have a single return statement, no loops, no local variables, and so on. But from C++14 onwards, the rules were relaxed. Now you can have local variables, loops, conditionals, and more. This makes Constexpr much more flexible. Here is an example of modern Constexpr function with a loop. You can now call this function in a Constexpr context, and the compiler will evaluate it during compilation. No runtime cost. Constexpr in classes. You can also use Constexpr with constructors and member functions. You can now create Constexpr objects like this. That's incredibly powerful. It means you can build entire object hierarchies that exist only at compile time. C++20 made Constexpr even more useful. For example, now you can use try-catch blocks, dynamic memory allocation, and virtual functions in Constexpr under certain rules. This pushes the boundaries of what you can compute during compilation. To wrap it all up, Constexpr is one of those features that once you understand it, it changes how you think about writing C++. It leads to more predictable, efficient, and cleaner code. And as compilers get better and the language evolves, compile time computation is only going to get more powerful. So next time you are writing a helper function or defining a value that won't change, ask yourself, can this be Constexpr? Thanks for watching, and if you found this helpful, don't forget to like, subscribe, and check out the playlist on the screen. See you next time.